Hi, my name is Mohammed Tariq. We have seen the recursive version, the recursive method of tree traversal, and we thoroughly discussed the steps of uh, applying the recursive version. And today's lecture, we will focus on the iterative method, and we will use the in-order traversal to understand the iterative function. So let's start the step-by-step process. I have a tree here. This is a demo tree, and I'll use this tree to make you understand how this iterative method works. So we will use the stack. We will use the stack to handle the traversal of the in order traversal, and this stack we will use to keep track of the nodes of our tree's nodes. So let's draw a stack here. So this is a stack. Initialize current node as root. So we have a current node here. So this is our root node, and this will be the current. Current is actually a pointer. Okay, current is actually a pointer we will use to keep track the current standing of our pointer. So what we will do is the third step is this was the first step. This is the second, and this is our third step. Push the current node to the S. S is actually denoting the stack. Push the current node to the stack and set current is equals to current dot left is actually a current dot left. I'm using the coding term. So here I've used the arrow to make you understand that it's actually referring to the left side of the current node until the current is null. So what we will do is it's actually a loop. Okay, it's actually a loop. We will keep on looping until we get the current as null. So what we will do, we will push the element. We will push the first element, which is 1. Okay, now the second element is, so the current will move from here to here because it's looping. Now we will push 2. We will push into the stack. Then we will push what? We will push 4. A pointer will move here, and we will remove this pointer from here. And now when we will try to access the next element on the left hand side, what we will get, it's actually a null here. So it's actually a null. Okay, the left side and the right side is actually a null. So when we get the null, we will encounter null. So pointer will come here. So this loop will stop. Okay, so the next line is, if the current is null and the stack is not empty. Now the current is null. So this pointer is showing us that our current pointer is standing at the null value. And stack is not empty. Stack is not empty. We have 3 elements in the stack. So pop the item from the stack. We will pop the latest item, right? So we'll pop the first item from the stack, print the popped item, set current equals to popped item dot write. This is popped item dot write. So whatever we have popped item, so the current is now actually pointing to the popped item. Okay, and we have popped this out, so 4 will no longer be there. And let's say we are printing it. We are printing elements here. We have popped 4, right? And then we will check its right side. So on the right side also it is null. Okay, the right side also it is null. And then we'll go to step 3. The step 3 says push the current node. So it's actually a null, so there is no need to push the current node. Okay, so the current is actually pointing to this node, right? So it's saying the push the current node to the stack. It's null. We need not to push this, and set current dot left. So it's null. We need not to push anything. Now let's come to the step 4. If current is null and the stack is not empty. Okay, so the current is null. Yes, current is null and stack is not empty. So pop the item from the stack. We will pop this item from the stack. Print the popped item and set current is equals to popped item dot write. We will print 2. We will print 2 here, and we will remove this from the stack. We'll remove 2 from the stack, and then we will check its current. Okay, we will check its right item. Check its right element, pop dot right. So the current is now actually pointing to 5. The right hand side of 2 is 5. So we will remove all these. Now go to step 3. Let's go to step 3. It's saying push the current node to the stack. We will push 5 here. We will push 5 here into the stack and set current is equals to current dot left. So this could possibly be true that we would have any element here. Okay, anything. For example, let's say 10 or anything. We could have something like this also. Okay, 101 or something like this also, and something like this also. 111. I'm just entering any value. I could have entered ABC. Just try to explain this. We could have something like this. So we need to take care of these nodes also, right? So if we would have something like this, so this line would translate into set current is equals to current dot left. So in this case, we have an element on the left hand side of the node 5. So in this case, this current will be pointing to the 10, and it will then not pointing to that 5. But in this case, the current in this tree, we do not have anything either on the left hand side or on the right hand side. So these are both null. Okay, so we have pushed the 5 here and set current is equals to current dot left. So the left is null, and it's the current pointer is actually pointing to this null element. Now the next step is if current is null and the stack is not empty. Current is null and stack is not empty, which is true. Both conditions are true. Pop the item from the stack. We'll pop 5. Print the popped item. We will print here. We'll print the 5 here. Let me write it. Print the 5 here and set current is equals to popped item dot right. So on the right hand side also we do not have any element. It's also null. Pointer is pointing towards the null of the right hand side. We'll go to step 3. Push the current node. We have null, so we need not to push it, this condition, and set current equals to current dot left, so it's null. We will come to the step 4. If current is null and stack is not empty, so what we will do, pop the item from the stack. The element we have in the stack is 1. We'll pop the 1 and we will print 1 here. Okay, print the popped item and set current equals to pop dot right. So now the pointer we have here, based on the stack's value, our pointer will be maintained. As you can see from here, from this point, our pointer will move to the element 1, which is the root node. And how it moves, based on the value in the stack, right? We will check the value in the stack and then we'll move the pointer accordingly. Now we have printed the element, so we'll remove this from here. Okay, and then we will check its right hand side, and yes, we do have an element on the right hand side of the one node. So what we will do is go to step 3. We'll go to step 3, push the current node to the stack. We'll push 3 here. We'll push 3 here and set current equals to current dot left. We could have values here also, right? As I just mentioned, we could have some value here, 111. Okay, we could have some value on the right hand side. So let me remove this to, okay, we could have some values here also. We could have something like this also. Okay, so this can possibly be the tree structure. So but in our current case we do not have anything like this, so we'll remove. And our current pointer is now what, is pointing to the popped item dot, sorry, we are here. Push the current node to the stack. We'll push 3 and set the current equals to current dot left, and the left hand side is null, and it's for the current pointing to this null element. So if the current is null and The stack is not empty. Current is definitely null and stack is definitely not empty. We will pop the item from the stack. We will pop this out from the stack and we will print. So now we will print 3. We'll print 3 and set the current is equals to popped item dot write. And when we will check, so the write is also null. We'll just pointing here, the current pointer and it's also null. Okay. And now so we have completed this tree. We have completed this the traversal of this tree using the iteration, using the iterative method. The last step is if current is null and stack is empty. So when we will pop this out as we have printed, this will become empty. Okay, we are pointing to the null element and the stack is also empty. Then we are done. Our iterative method of traversal has been completed.